Hi everyone, my name is Chris Blake and I've been working as a SaaS user and administrator for over 10 years. During this presentation, I'd like to share with you why I think that root cause analysis and mean time to resolution are important and why teams of all sizes should be using these methods. I'd like to take you through some of the resources that I have for helping you and your teams to improve your performance by making your root cause analyses more efficient and effective and helping you to close issues faster. If you've been working with SaaS for a while, particularly in clinical trials or maybe manufacturing, then you might have heard of root cause analysis. Particularly if you've been working in IT, you might, particularly in larger companies, you might well have also heard of mean time to resolution. But I'm often surprised by how often I work with teams that haven't heard of either of these things, especially in the context of SaaS and SaaS administration. Let's start with an overview then of both root cause analysis and mean time to resolution, and then we can dive into each one of them in just a little bit more detail. Let's start with mean time to resolution, or MTTR, if you like an acronym. Atlassian, the company behind tools like Jira, define mean time to resolution as the average time it takes to fully resolve a failure. The resolve word is important here because it means we are including not only the time spent in detecting the failure, diagnosing the problem, and repairing the system or program, but also the time spent understanding what happened and taking the corrective actions to ensure that the problem won't happen again. That final understanding and correcting piece is root cause analysis. Root cause analysis is generally defined as being a method of problem solving for identifying the underlying cause of an issue. The underlying cause is the important part of this definition, fixing the actual problem so that it doesn't happen again. I know that we're all guilty of putting a metaphorical band-aid on a system by knowingly fixing a symptom rather than the actual problem. I hope that by now, and even perhaps before this presentation, we all understood the benefits of fixing the real cause of a problem rather than just the visible symptoms of it. Using root cause analysis helps us to uncover these real causes, and that's important as an administrator because it should mean that our platform is more stable. Equally, if we can reduce the amount of time it takes to resolve each issue, we will end up with happy users. And as SaaS administrators, that's our ultimate goal. So let's go a little bit deeper now and explore each of these items in a bit more detail. Mean time to resolution. Where did this term come from? Well, unsurprisingly, it's a term that's been around for a long time and originally referred to how long it took to fix a piece of machinery in a factory or a plant. There are probably a couple of other similar terms that you might have heard of when thinking about things like mean time to resolution. Mean time to recovery and mean time to restore. These are subtly but importantly different from mean time to resolution. Restoring or recovering the system means getting it back online, but we haven't necessarily fixed what caused something, perhaps a program or a job, to fail or take the system offline. Mean time to resolution is calculated by dividing the amount of time spent resolving incidents by the number of incidents that we've had. So say we're calculating our mean time to resolution for April, and we've had 2 incidents, and one took 8 hours to resolve and one took 24 hours to resolve. Our mean time to resolution for April would be 16 hours. Something to note here is that we typically only count business hours in our mean time to resolution calculation. If the administration team has an agreement with the business that the SaaS environment needs to be available 9 till 5 in the day, we'd only count time spent working on these issues during these hours. Of course, in reality, the system might be offline or that code unavailable for much, much longer. So why do people use mean time to resolution? Well, there is a correlation between mean time to resolution and customer satisfaction. As administrators, we want to have happy users. Another reason is that teams can measure and track their performance. This can be done individually at the administrator level, at the team level, or even across teams. As we saw from how the metric is calculated, there is no specifics about the technologies used, and it's easy for people to understand. Of course, this can be a double-edged sword, especially if there's not a shared understanding of the definition of that word resolved. We've discussed how we can objectively measure our performance as administrators by using mean time to resolution for issues. But we haven't yet discussed in major detail a major component of that resolution part. That time spent understanding why a problem happened and creating a plan and implementing changes to ensure that it doesn't happen again. Root cause analysis is a process to help teams find out what happened, why it happened, and determine how to prevent future occurrences of the same event. There are a few different techniques for performing root cause analysis. They all involve getting a small team together and systematically working through the problem. We're going to take a look at a scenario using just one of those in this presentation. Some administrators and support teams, whether they know it or not, probably already do a form of root cause analysis on their issues. It's quite likely that, as an administrator, you've been asked to provide an explanation as to why an outage occurred or an incident happened. And I hope that you were able to answer that question and what was likely the follow-up question. That thing that happened, is that going to happen again? Regardless of the method used, root cause analyses are normally delivered in a report form and contain 4 major parts. A clear problem statement. Being able to clearly describe a problem shows that the problem is well understood. And if a problem is well understood, then we likely stand a better chance of being able to resolve that problem. A timeline from normal operations through when the problem occurred. Establishing what happened in the run-up to the failure helps us to understand the relationship between all of the events that happened in the environment and that may have contributed to the failure. The time frame might be a few minutes or might be several days. Pulling all of these events into a sequence also helps with the next stage of the process, which is to distinguish between the root cause and other causal factors. How we distinguish between something that occurred because of the failure or the failures themselves. It's likely that when a failure occurs, we're going to see lots of warnings and errors in logs in different parts of the system. It's important that we're able to understand and organize all of these things that have occurred and categorize them as either a root cause, a small causal effect, or a symptom of the problem. Finally, as with any good report, we should identify the corrective actions that are required. The root cause analysis report should identify the actions that are required or have been taken to resolve the problem and justify why those actions should prevent the same problem from happening again in the future. If a fix is not known or cannot be implemented, the report should document why this is the case. I think that the 5 whys method of root cause analysis might be the simplest method, which is probably why it's also my favourite method. The method simply involves asking why about 5 times. Let's contrive a simple example to go through this, something that we can all imagine. We've come in on a Monday morning and one of the developers tells us he's received an email to say that his job or his flow has failed. He's tried to see if the data that he needs to start his day and carry on with his work is there, and it's not. The error that was in the email that he got sent says something about a lock on a data set. Now, each of the following stages that we're going to go through might take us quite some time to answer, but the point of the exercise is get to a place where we believe we know the root cause of the issue, and there might be more than one root cause. So let's have a go at this, shall we? Why was there a lock on the data set? This one we might have to look at the SAS lock to help us answer, and we find that was because another program was using the dataset. Well, why was another program using this dataset at the same time? For this, we might need to find out what the process was, what program was it, and why did it use the dataset too? We find out that it's another regularly run job and that this program took 5 times longer to run than it did normally. Why did the program take 5 times longer to run than normal? Possibly back to our SAS logs for this, maybe speak to the developer. In the end, we see that it was because it needed to process significantly more data than it normally does. Well, why did the program need to process so much more data than normal? This is getting deep now, but actually, speaking to the team that owns the job and digging through all of the log files on the server, we find that it was because this program had actually not been run for the previous 7 days. Well, why had the program not been run for the previous 7 days? We talked with the developers that own this code again, and we find that it was because the program is run manually, and the person who normally runs this program was on vacation. We can see from this example that the method is interactive and iterative, and if the answer to the first why doesn't provide what the root cause is, then we continue to a second round of whys, and so on and so on. Although the method is called the 5 whys, this is just a rule of thumb. If you get to the root cause sooner, great. If you need to continue asking more whys, then you should obviously carry on doing this. In our example, I can see that we have 2 root causes that we could design and implement changes for. The first root cause is identified during our second round of questioning. There is an unhandled dependency between the job that errored and the job that overran. If the job that failed is just scheduled to run at a specific time, then maybe we could update the dependencies between these 2 jobs to either be on completion or have the second job wait for some kind of trigger file created by the first job before starting. How you implement the resolution to the first part might depend on the technologies that you have available to you at your organization. Our second root cause is discovered in the last round of questioning. We have identified that there is a manual dependency somewhere in our workflow. There is a job on which other jobs have a dependency that is triggered manually. We need to either update the process such that when that person goes on holiday, someone else is able to run this job, or ideally, this job should be scheduled using proper scheduling software. We've been through what mean time to resolution and root cause analysis are, and I hope so far that I've impressed upon you why I think both of these things are important for all SAS administrators, regardless of whether your company is big or small. If you're already performing root cause analyses on your system incidents, great. If you're already using mean time to resolution to measure your team's performance, amazing. But do you wish that you could perform your root cause analyses more efficiently? Do you wish that you could improve your mean time to resolution number and improve the performance of your SAS administration and support team? I want to highlight just a couple of areas that I know teams can look at to help improve their mean time to resolution number. Perhaps this short list will inspire you to think of some more things that you might be able to do within your own organization. Put SLAs on customers too. If someone has said that something is important and is expecting that we respond with a certain amount of time, I think it's reasonable to expect the same of them. That might be a pretty bold statement. However, I don't mean we should be really draconian and impose SLAs on all things. We're only looking to use these SLAs if customers are continually being slow to respond. But we also need to ask ourselves why they are taking so much time to respond. Is it because they're busy with their day job, or is it because is the cause as much our fault as it is theirs? Are we reviewing the questions and the answers that we're providing back to them to ensure that the next steps that we're maybe asking them to perform are clear? SAS is hard, at least I think it is. Some issues involving SAS are really difficult to solve. There are just so many moving parts. What we can do, though, is make sure that we keep people informed so they know what's going on and that Salman is still looking into their problem and is still working through all of the detailed information that we've asked them to provide. This might seem formal, especially if you are working in a internal, for an internal support team or in a small organization. Nor might this directly impact our mean time to resolution number, but it should definitely help ensure that our users are happy about the service that we're providing. And like I said earlier, as SaaS administrators, having happy SaaS users is our ultimate goal. Glacial-paced teams. There is an inevitability and a dread to this. Within each organization, there are teams that you love to work with, and there are teams that you dread working with. You're desperately hoping that the problem isn't a firewall issue because those guys are just so slow to work with. Well, is there something we can do to help? Is there a process issue where maybe we aren't providing enough information to that team to help them to be able to do what they need to do? Is there a resourcing issue that we can speak with senior management about to help us, and get them to help us to address it? Resolution time outliers. You might normally resolve issues within a few hours or a day or so, but occasionally something comes across the team's desk that's just really, really difficult. There are lots of internal teams involved, as well as one or more external vendor support teams. These issues really drag the numbers up. Controversially, maybe, I'm going to say, let's have a look at the number that we're reporting. Is the median time to resolution a fairer representation of your team's performance? Can you justify to senior management that using this metric instead? In some instances, it might be a much fairer metric to report than the commonly accepted mean. I'd also like to highlight a few points that I think will help people start their root cause analyses journeys, or help their existing root cause analyses become more efficient. I know that there are many people out there who try and perform post-mortem wrap-ups after system issues. However, in my experience, these have mostly focused on how the platform could have been brought online quicker, rather than focusing on the underlying cause of the issue and the resolution of that. Try and avoid including people involved in the incident in the analysis. This doesn't mean to say don't get the information from them. We should absolutely be doing that. What I mean by this is that, if possible, the developer involved in writing the code or the administrator who led the recovery effort shouldn't be part of the root cause analysis team. We want to interview them and understand everything about what happened, but there is a tendency for people to be defensive and not objective when working through an issue that they were really closely a part of. Use a multidisciplinary team. The objective of root cause analysis is to find the cause of an issue and design and implement changes to ensure that they won't happen again. People from different parts of the organization and from different teams think differently. And that change in perspective might just be the key to unlocking the cause of a problem or designing a really great change. Frame questions around facts and not hypotheses. This is particularly relevant when we are using the 5 whys method of root cause analysis. We need to ensure that we frame our questions that we're asking of the team and of the data to be around the facts and what we're seeing, rather than hypotheses that we have about what causes might be. Finally, we should make use of the great tooling that is available to us to help us navigate through all of the different data that is available about an issue, and take advantage of resources that are available to help us to conduct and present our analyses. In the GitHub repository for SaaS Global Forum 2021, under the folder for my paper, I have included a couple of resources as well as some sample root cause analysis templates that you can use for structuring and sharing reports within your organization. Even with the simple example that I went through earlier in this presentation, we can see just how much data, like log files, but also interviews with different people, a team or person would have to dig through in order to solve a simple issue like the one we just created. But as I'm sure many of you will know, working out which job or user or program ran under a given process ID on a given server on a given day at some point, even in the recent past, can be really, really difficult. Therefore, one of the biggest things that you can do is to instrument your SaaS environment with a really decent observability tool. Something perhaps like Bo Emsker's Enterprise Session Monitor, or ESM. Not only will you be able to recover and restore your system faster by being able to find problematic processes and SAS sessions in real time, but because ESM stores all of that data it captures about your SAS sessions, you can go back in time as far as you need to construct your timeline of events. You can browse and search for specific jobs, users, flows, process IDs, and even errors. And you can open up the log files for your SAS programs right from your browser. It's incredible how much faster you can discover the real cause of your outages. In conclusion, if you're not currently performing formal root cause analyses on your issues, I hope that you can see that there are simple, interactive methods that are easy to work with to help you do these. These methods, supported by the best tooling, can really help you to get to the bottom of your issues faster. Resolving issues faster and with more confidence will help you to bring down your mean time to resolution number, which is shown to be linked with customer satisfaction. As we all know, stable performance systems equals happy users, and happy users equals happy administrators. I hope you found this presentation interesting and useful. I definitely encourage you to check out the paper in the proceedings. I go into a lot more detail about the different methods and techniques for performing root cause analyses, and even more reasons, not that you need any, as to why I think all SAS admins should be performing root cause analysis and measuring their performance using metrics like mean time to resolution. If you have any questions, please don't hesitate to get in touch. Thank you.